All right. So first thing we're going to do is learn how to graph square root of x. Now square root of x is a curve that looks like this. Let's graph this over here really quick so you see what it looks like. It looks something like that. So this is adjusting that original graph. So first the half. The half is going to lower the speed. So it's going to go up much slower. It's not going to go as fast as this one. So it's going to go slower. So that's one change. The other thing that has changed the original graph, which is this one here, is going to be the plus 2 inside of the square root. When you have a plus 2 inside of the square root, it's actually going to do the opposite of what you think it's going to do. It's not going to move it to the right, it's going to move it to the left. So not only is the original one moving to the left, 2, it's also going to be going up slower. So something like that is what I'm looking at. Okay, and it looks like a straight line, but it's like a curve. Okay, and that's what this has done to the original graph. Now, this is also shift to the original graph. The minus 3 outside of the square root means it goes down 3. So now we know that it's gone down 3. So now we know the start point is here. The negative sign means it has flipped. So it's not going up like this, it's actually going down. So it's going to be something like this. Okay, so that's that one. So negative sign means it flips, and the minus 3 on the outside of the square root means it goes down. Okay, this one has a couple things happening. So the first thing is it's going to go to the right 3 because it's inside of the square root, so the minus sign is going to actually make it go to the right. So it's going to go to the right 3. And then this, because it's outside of the parentheses, is going to go up 1. Now from this dot is going faster, so 2 times faster, but in the opposite direction. So it's actually going like this. And there's our graph. Okay? Radical graphs. All right, next. Now we're simplifying radicals. So to simplify this radical, you have to think of 2 numbers that multiply to make 54. So which 2 radicals multiply to make 54? We're thinking square root of 9 times the square root of 6, right? Now we can still split this square root of 9. Square root of 3 times the square root of 3. And the 6 turns into square root of 2 times the square root of 2. Oh, square root of 2 times the square root of 3. So let's put a 3 here. That was my bad. And that's it. These are all prime numbers. The only way I can split them is if I use ones. So that is our bottom. So what we have now is a 3, a 3, a 3, and a 2 inside of the square root. And they're all multiplying. So when you have a pair like these two, it actually gets outside of the square root and turns into a singular number. So now we have a 3 on the outside. And what's left inside is this 3 and this 2. So it's going to become 6. So 3 square root of 6 is exactly the same as the square root of 54. Okay? Why? Because the square root of 3 times the square root of 3 equals 3. Any square root times itself will have the square root cancel. It's like squaring a square root. So here, square root of 5 and square root of 10 are going to multiply. Okay? So if they're going to multiply together, we need to see if they have anything in common. The square root of 5 can't simplify anymore. So that is already a prime number. This square root of 10 can turn into square root of 5 times square root of 2. So I have 2 other prime numbers. So this is actually 5 times 2 square root. So again, there's a pair of 5s, so it's going to come out and become one singular number. So 5 is on the outside. What's left inside is a 2. So the answer is 5 square root of 2. All right, now we're going to go here, simplify this. Now the 56, I think we already did the 56. Oh, no, that's 54. So this is going to be, for 56, what 2 numbers go into 56? So I'm thinking 28 and 2, right? What else? We have 14 and 2, right? Prime number, prime number. This turns into 7 and 2, right? Prime number, and we're done. So what we're left with is 2, 2, 2, and 7 at the bottom. Now we need a pair to get out. This pair turns into a singular 2, and the 2 and the 7 stay inside, so it becomes a 14. And the answer for this is 2 square root of 14, but we have to deal with these letters here. So the x is all by itself. So that's going to stay inside. Okay? The y, there's 10 of them. So there's 10 y's. And every 2 is going to come out 1. So every 2 y's is going to turn into a singular y on the outside. So what we're going to have on the outside is y to the 5th power. Because every 2 is going to become 1. Same thing here. Every pair of z's, there's 5 z's, every pair is going to come outside. So that's going to be left with a z to the 2nd power with a z left inside. Okay? Because there's z, 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 z. All right? And 1 comes out, makes a z. Another comes out, makes it z squared, and a z is left inside. So there's no more y's inside. So our final answer is 2 y to the 5th z squared to the 14 x z. Now let's do this one. Square root of 45 over 10. Now another way of writing this is the square root of 45 divided by the square root of 10. Now you're not allowed to have the square root on the bottom. So what we're going to do is multiply this by 1. So square root of 10 times square root of 10 makes 10. But to make sure that I can even do that, I have to also multiply the top by the square root of 10. Because the square root of 10 divided by the square root of 10 is 1. Any number divided by itself is 1. So I'm not changing this number because I'm just multiplying it by 1. I'm just changing the way it looks because we're just simplifying it. So square root of 10 times square root of 10 gives me 10 on the top. And the top is going to end up to be the square root of 450. Okay? Now that's a pretty big number, so we're going to shift over here. So that's going to be the square root of 450. So let's simplify that top because we can't leave it like that. So we know that this is divisible by 25, right? How many 25s go into 450? That's going to be 4 for 100, 8 for 200, 12 for 300, 16 for 400, plus 2 more, that's 18. So that's going to be the square root of 25 times the square root of 18. Now I know the square root of 25 is 5, so I can already kind of go there. Now the square root of 18 has the square root of 9 and the square root of 2. Again, I know the square root of 9 is 3. So now I'm just left with the square root of 2. So 5 is on the outside and 3 is on the outside and a 2 is left inside. So that's 15 square root of 2 over 10 is our final result. The 10 was already there. 5 times 3 turns into 15. There's our result. Now, I can simplify this. They're both divisible by 5. So now I'm left with 3 square root of 2 over 2 because I simplify 15 over 10 and turn it into 3 over 2. Final answer there. Same thing here. Now here, again, you can't have square roots on the bottom. So what I'm going to do is multiply it by 1 again. Now, I'm going to multiply it by its conjugate of the denominator. So it's going to be 3 plus square root of 7. And 3 plus square root of 7 again over here. Now what's going to happen is this is going to multiply with that. So it's going to look something like this. 3 minus square root of 7 times 3 plus square root of 7. Now it's going to be 3 times 3, 9. And it's going to be positive square root of 3 square root of 7. And this times this is going to be a minus 3 square root of 7. So this is going to cancel. And then I'm left with square root of 7 times square root of 7, which is just negative 7. Because it's a negative times a positive. It's going to make negative 7. So we're left with 9 minus 7. The top is going to be 7 times 3. That's 21. 7 times the square root of 7 is 7 square root of 7 equals 21 plus 7 square root of 7, because I can't combine those like terms, and this becomes 2. And I am done with that one. Now, I kind of bled into this one over here. Now, this one looks complicated, but in reality, it's very simple. You're just combining like terms. 4 square root of 3 combines with minus 6 square root of 3, and that becomes negative 2 square root of 3. The positive 3 square root of 7 and another 3 square root of 7 becomes positive 6 square root of 7. You can't combine these like terms. Final answer is right there. Now we're up here. That is going to be 54 square root of 54 plus 2 square root of 24. Now 54, let's see here, is divisible by square root of 2 and 27. I know 27 is divisible by square root of 9 and the square root of 3. Now 9 I know turns into 3. Square root of 9 is 3. So I'm left with these two. There's no pair, so they're inside. So it's square root of 6. The next one is square root of 24. Square root of 24 is square root of 4 times square root of 6. Again, I know square root of 4 is 2. So it's going to be plus 2 square root of 6 left over in the inside. Because this is going to become square root of 2, square root of 3, and that stays inside, so then it's square root of 6. Combine like terms, and you're going to get 5 square root of 6. Here, you're multiplying. So 9 times the 11, so you're going to multiply the whole number with the whole number, so that's going to make 99. And you're going to multiply 5 times 15, so that makes 75. Now I can simplify the 75. That's the square root of 25 and the square root of 3. I know the square root of 25 is 5. I can just go to it. And the leftover number is square root of 3. So now 5 is outside with the 99. Okay, so this is going to be 500 minus 5. So it's going to be 495 square root of 3. Wow, that's a big number. Then over here, we're going to do the distributive property with this. Again, the 3 multiplies with the 4 and makes 12. The square root of 2 times the square root of 3 makes the square root of 6. The 3 times the 6 gives me 18. And the square root of 2 times the square root of 2 makes just regular 2. So 18 times 2 is going to make 36. And there's our final answer. All right, that's it.